This is our physics extra credit movie scene analysis by Cole Smith, Cole Bosenhart, and Malachi Church. The scene we chose to do our project on is from the movie Indiana Jones and the Temple of Doom. This scene consists of Indiana Jones and a man using his bullwhip as a rope swing/pendulum to get across a gap in the temple. We are trying to calculate if it would be realistic for Indiana to be able to use his whip without the whip snapping from the tension. We will just be focusing on Indiana, not the man, as information for his weight and not readily available. The scene of this movie is linked below, and only watch the first 20 seconds. These are all the formulas we used for our analysis. We had tension, kinetic energy, potential energy, and then we used the velocity equation, or the kinematics equation to solve for acceleration, and then the equation we looked up on Google for the height difference. And this is a picture of Indiana Jones. And these are our variables we started with. We had known variables and unknown and estimated variables. Our known variables are Indiana's mass, which we looked up online, which is 79.38 kilograms, and the whip length, which is 2.44 meters, which is converted to 8 feet. Our unknown and estimated variables are the gap length and angle from whip to ground, which are 3.657 meters and 12 feet, and the angle is 45 degrees.
Alright, so for solving for the difference in height, we use the equation we found on Google. The variable h represents the height in meters in which Indiana would have dropped when he swung into the pit. Since he would not have been level with the ground, we had to use Google for this formula because he was going to be lower when he started swinging. For solving for potential energy, we just use PE equals m times gravity times the delta x. This potential energy was then converted into kinetic. And then for solving for velocity, first we used the kinetic energy equation. We obtained the kinetic energy from the delta PE from the previous slide, and then we used this along with Indiana's weight to calculate his velocity.
Solving for acceleration. To solve for his acceleration, we used the kinematic equation for velocity, excluding time, because we did not have the time that it swung, that he took to swing across the pit. So we used v squared equals v initial squared plus 2a times delta x, and we plugged in our calculated velocity and our estimated pit length and got a final acceleration of 1.92 meters per second squared. Now for tension, we solved using the formula above, T equals mg plus ma. We plugged in his mass, which was 79.38 kilograms, the force of gravity, which was 9.8, his mass once again, and our estimated acceleration. And for the final tension, we got 930.33 newtons. Conclusion. We calculated the tension on his whip to be roughly 930.33 newtons. After looking up the amount of force required to break apart a braided leather bullwhip, we found it to be roughly 2,000 newtons. Based off of this, we can conclude that this scene would be possible and could be done in real life because the force required to break the whip in half would have been over double what he produced in that movie scene. And this was all of our work that we did on the library whiteboard.